would you be kind enough to start? On page 642.
Oxidation reduction reactions between non-metals. We have seen that oxidation reduction reactions are characterized by the transfer of electrons. In some cases, the transfer literally occurs to form ions, such as in reactions 2Na plus Cl2 to NaCl.
So everybody just look at the example. We're not going to make people read the examples. They don't really read too well.
We can use oxidation states to verify that electron transfers have occurred.
So stopping there, you're supposed to be able to figure out numbers. If they do not write any charge, that means the charge is 0. Once they're in a compound, they have been playing around with electrons. What charge is on chlorine in a compound?
-1.
So can everybody get the -1 number? In redox reactions, the charges must balance as well as the number of atoms. Every time one atom of sodium goes over, there's a 1 electron change. In this case, that electron is being lost. That's why he ended up being positive, because Ben Franklin decided electrons were negative. Life would be simpler if Ben Franklin decided they were positive, but we're kind of stuck with it. We're not going to go back and change it. That's arbitrary. I mean, if you can make it positive, and he knew that.
How did they know all this stuff without having any?
They experimented.
How did they know that there's itty bitty things out there?
Because they stuck a lot from their.
Well,
They
actually, I kind of found out something about yourself at the prom thing. We actually started experimenting with cats. And you would create static electricity. Yeah, we eventually worked out to figure out that there's infinite charge. But you're right, it's hard to discover some of this. Some of this is what you did in the experiments. If you want to find more experiments, we could do the next experiment where you break it down and figure it out. But I thought we went better to sort of get the theory down. So there's a 1 electron change for each atom of sodium. For each 1 atom of chlorine, there's a 1 electron change. In chlorine's case, it's gaining. You can't have gain without loss. You can't have loss without gain. The electrons just don't go off into some never land.
So the red line is
So the red line is between the chlorines and the black line is between the sodiums. it helps you to maybe know it's a game, but you don't have to figure that out. The number of electrons must balance. So that means that I need to have one atom of sodium go over so that each one gains one for each one atom of chlorine. If I want just one atom to go over, this guy appears as a 2, so he comes a pair at a time. If I put a half in front of that, that would mean that one chlorine atom is going over. That would balance that chemical equation. Because I would have one atom of chlorine, one atom of sodium. I would have many electrons gained and lost. If I count it up, it balances the same way. So I've got sodiums and chlorines balancing the same way we did before. If you do not like to use fractions, you could have done it by having 2 atoms here and 2 atoms here. The way that I would get 2 atoms of chlorine going over is if that number was a 1. And I would put a 2 there. And I would put a 2 there. Okay. I'll do that. You need to kind of watch out for it here, so if you guys need stuff, you take care of it.
All the elements can go in the hot one.
They invite everyone.